Welcome back to the Massive Loop tutorial series. I'm Tim, and today we'll be taking the next steps in bringing anime-inspired mechanics to life using C# in Unity for Massive Loop. For those of you who aren't familiar with Massive Loop, it's possibly the most powerful platform for Unity developers looking to build metaverse and spatial computing experiences. It allows you to leverage your Unity skills while adding a suite of tools such as hosting, multiplayer, cloud persistent variables, and avatar toolkits for VR, desktop, and WebGL. It's also trusted by universities, businesses, and Unity game developers alike. In our last video, we explored how to implement a dynamic energy beam, allowing players to unleash powerful blasts from their hands. Today, we'll take it to the next level by making the city environment destructible when hit with the beam. We'll also dive into some basic synchronization to ensure the destruction happens in sync with all clients in the room. With that being said, let's jump right into the tutorial. Now, before we start scripting the city's destruction, let's take a look at some of the skyscraper prefabs to understand how the destruction will work. Each skyscraper prefab has three main objects: the original skyscraper, a replica of the skyscraper with a rigid body attached to it, and a large smoke particle effect. The skyscraper replica also has smaller particle effects placed at specific areas around the object. The purpose of these particle effects is to simulate a building collapsing. The way this entire system works is that when the beam hits the main skyscraper object, if the health of the object reaches 0, it sets the original skyscraper's mesh renderer to inactive and activates the skyscraper's replica and the smoke particle effects. Since the replica has a rigid body attached that uses gravity but does not have a box collider, the building will simply fall through the ground, which simulates the building collapsing downward. Originally, I tried using certain assets from the Unity Asset Store. However, for this particular case, since the city is quite large, it just wasn't very performant, so I had to go with a more structured approach. Now that we understand how the destruction will work, let's go ahead and create the script and start scripting the city destruction logic. First, let's create a game object and call it City Destruction. Then we'll create a C# script and give it the same name. At the top of the script, we'll add a few variables that we're going to need for our script to function. First, let's add a singleton instance of the class. This creates a public static property called instance. It's part of the singleton pattern, ensuring that only one instance of the city destruction class exists throughout the game. This allows other scripts to easily access this instance without creating multiple copies. Next, let's add a game object array to hold parent objects in the scene. This array will store all the main game objects in our scene that contains the buildings we want to manage. By referencing these parent objects, we can easily access and manipulate their child objects, which will be the individual buildings. We'll then define several public float variables to control the behavior of our buildings. Max health, which sets the maximum health value for each building. Destruction cooldown, which determines how long a destroyed building remains inactive before being restored. Destruction timer, which specifies the delay before a building is set inactive after being destroyed. Shake intensity and shake duration, which controls the visual shake effect when a building takes damage, enhancing the feedback to the player. Damage cooldown, which defines a time window to prevent rapid consecutive damage, ensuring damage is registered in controlled intervals. We'll also create lists to hold data about our buildings and their states. Buildings, which store the original building game objects. Replicas, which hold replicas or damaged versions of the buildings to display when a building is destroyed. Smoke objects, which contain smoke effect game objects that appear upon building destruction. And health values, which keep track of the current health of each building. To reset buildings to their original states after destruction or damage, we'll create lists to store their original positions. These lists help us maintain the initial placement of all related game objects, allowing for accurate resets and consistent gameplay. We'll also manage shake effects using coroutines. This list keeps track of active shaking coroutines for each building, so we can stop or manage them as needed when the building stops taking damage or is destroyed. Finally, we'll create an event token and an event identifier. Token is an event token used to manage event subscriptions, ensuring we can unsubscribe from events when they're no longer needed. Event ID is a constant string that identifies the destroy building event. We'll use this ID to subscribe to and trigger events related to building destruction within our event system. By setting up these variables and data structures, we're laying the foundation for managing building health, destruction effects, and restoration. After setting up the variables we need at the top, the next logical step is to initialize our script so it can start managing the buildings in our game scene. First, we'll create the awake method. This method is called when the script instance is being loaded, and it's the perfect place to initialize our singleton instance and register our buildings. In this method, we're implementing the singleton pattern by checking if the instance is null. If it is, we'll assign this to instance, ensuring that there's only one instance of city destruction in our game. This is crucial for consistent management of buildings across the scene. We will also call register buildings, which we will create shortly, to initialize and store references to all the buildings we'll be managing. If an instance already exists, we will destroy the new game object to maintain the singleton pattern and prevent duplicates. Next, we'll set up the start method to subscribe to any necessary events. This method is called before the first frame update, making it ideal for event subscriptions. In the start method, we will subscribe to an event identifier by event ID, which is destroy building. This will allow our script to respond when this event is triggered elsewhere in the game, such as in a multiplayer scenario where another player destroys a building. We will store the event token in token so we can manage the subscription lifecycle appropriately. Now, let's define the register buildings method, which will scan through our parent objects and register each building. In the register buildings method, we will loop through each parent objects to find all buildings in our scene. For each building, we will identify its replica and smoke effect object. We will ensure replicas and smoke effects are inactive at the start to prevent them from appearing before a building is destroyed. Then we will give each building a unique name to easily reference them later, and we will save their original positions so we can reset them after destruction. Each building and its related data will be added to our list for easy management. This setup will allow us to manage all buildings efficiently during gameplay. Next, we'll create a method to handle when a building takes damage. In the damage building method, we'll search for the building by name in our buildings list. If the building's health is above 0, we'll subtract the damage amount from its health. We'll then initiate a shake effect to visually indicate damage. If the building is already shaking, we will reset the coroutine to continue the effect. If the building's health drops to 0 or below, we will stop the shaking effect and proceed to destroy the building by calling destroy building. This method will provide immediate feedback to the player and manage the building's state based on its health. We'll now define the coroutine that handles the shaking effect. The shake building coroutine will provide a visual indication that the building is taking damage by shaking it randomly within a defined intensity range. We'll shake the building for a duration specified by shake duration, updating the elapsed time each frame. After the shaking effect is over, we'll reset the building's position to prevent displacement over time and clear the coroutine reference to allow future shakes. This effect will enhance the player's experience by providing immediate visual feedback. We'll add a method to stop the shaking effect when necessary. The stop shake method will ensure that we don't have multiple shake effects running simultaneously on the same building. If a shake coroutine is running for a building, we will stop it and reset the building's position to its original state. This will prevent visual glitches and keep the building's behavior consistent. Next, we'll define how the building is destroyed once its health reaches 0. In the destroy building method, we'll first invoke a network event to notify other clients in a multiplayer game about the destruction. We will then activate the replica and smoke effects to visually show that the building has been destroyed. The building's collider and renderer will be disabled, so it no longer interacts with the game world. If there's an audio source attached, we will play a destruction sound to enhance the player's experience. Finally, we'll start coroutines to handle the destruction timing and the eventual restoration of the building. This method will manage the entire destruction process and prepare the building for restoration. We'll ensure that when a building is destroyed, all clients in a multiplayer game reflect this change. The destroy building others method will be similar to destroy building, but will be specifically called when the network event is received by other clients. This method will ensure that all players in a multiplayer environment see the building destroyed at the same time. maintaining consistency across different game sessions. By replicating the destruction logic, we will ensure that the game's state remains synchronized for all players. We'll define a coroutine to handle the timing before we deactivate the destroyed building and its effects. The destruction timer coroutine will wait for a specified duration defined by destruction timer before deactivating the destroyed building and its effects. This will allow the destruction effects to play out fully before cleaning up, enhancing the realism of the game. Deactivating unused objects will also help maintain game performance by freeing up resources. Finally, we'll create a coroutine to restore the buildings after a cooldown period. In the restore building after cooldown coroutine, we'll wait for the duration specified by destruction cooldown to simulate a rebuilding period. We will then reset the positions of the building, replica, and smoke object to their original states. Any rigid bodies attached to the replica will be reset to prevent unexpected movement. We will re-enable the building's collider and renderer, reset its health to max health. This will allow the building to be destroyed and rebuilt multiple times during gameplay, adding depth and replayability to the game. Now let's head back to the editor to complete the setup process. Add the City Destructor script to the City Destructor game object, then drag all the parent objects of the buildings into the parent objects array. Set the max health to 1000, destruction cooldown to 10 seconds, destruction timer to 5 seconds, and for shake intensity, shake duration, and damage cooldown, we'll set those to 0.5. Lastly, we need to ensure that all the buildings are set to the same layer. For this particular example, we'll be using the layer 4, which is the water layer. Now that we have our city destruction script and setup process completed, we need to trigger the building damage function from our beam weapon. If you don't have the energy beam script, be sure to watch the previous tutorial to get up to speed. Open the energy beam script and navigate to the shoot raycast enumerator. First, we'll need to check if the beam is hitting a building. If so, we'll get the building's name and then call the city destruction singleton reference to trigger the damage function, passing in the building name and damage amount. And that's all we need to do to this script. Now let's test our creation. When I fire the beam, the building shakes and eventually the destruction is triggered. After the 10-second cooldown, the building is restored to its original state. That about wraps it up for this tutorial. Thank you guys for watching, and I'll see you in the next one.